Hello, my name is Elena and I am a tutor at Programming Homework Help. Today I'm gonna show you how to evaluate an expression using ARM assembly. This program will be used to evaluate an expression using ARM assembly, reading and printing decimal and hexadecimal numbers using subroutines. We start defining some of the messages we will use for the program, like the message for asking the user to provide number and the different signs that will be used for the equation, like the minus, sum, and equal signs. .skip directive will omit 11 bytes to save space for each number. Now let's remember that a buffer is in a location in the memory that holds the data before it gets processed, so we will give this 20 bytes. And hex table, which will have a reference string with the hexadecimal characters. .valin with advanced location counter until it is a multiple of 4. This .word directive expects 0 expressions for these sections. With this section, we provide a starting address to the start linker, and we set an input buffer size of 10 bytes. The start section will be using these functions and subroutines that I'm gonna describe next to convert these numbers to an hexadecimal form. This starts asking the user for the first number, considering the maximum number of bytes a number can have. Then we convert it to an integer value and we save this in a variable. We repeat the same actions for the 4 numbers. The next section will write the whole equation using the 4 numbers given in the sum form. Now this part calculates the result of the equation like it shows here, and it saves the result to print it. Then this part prints the address of each of the given numbers. At the end we will have these commands that indicates a number completion and terminates the program. As I said before, here we have the subroutines, or the steps to convert the input decimal numbers into hexadecimal numbers. The first subroutine will divide the number by 10 and will return the result. The second subroutine converts the input string into an integer to be able to do these operations. The convert section loads the string to convert. The start conversion makes the conversion to an integer value. Then we check if we need to add a negative sign, and we finish by returning the converted number. The next subroutine is used to print an integer by using the previous mentioned buffer functions: division, conversion back to ASCII, and making a loop to repeat the operation as long as the number is not 0. Then we print the result. The next subroutine is used to print the number as an hexadecimal number. This again with the important participation of the buffer command to save the values. Then we use a print loop to reach each hexadecimal digit using the given table. We finish printing the results. GetString subroutine provides a pointer to insert the string from the terminal. This will be realized commonly with the keyboard. Then we restore the contents and we return the obtained string to the calling program. This last put string subroutine allows to display the final string to the terminal. We have a part that stores the string, a loop that reads each character of the string, and finally a print function in which will define a standard output, commonly a monitor. All of these subroutines were used along this start global function. We hope this video was useful for you. For any assistance, you can visit our website programminghomeworkhelp.com or send an email to info@programminghomeworkhelp.com. Thanks for watching.